Welcome to the deep dive.
Thanks for having me.
You know, uh, today we're diving into something that's a pretty big hurdle
Yeah.
for a lot of people hoping to make it big in the cloud. We're talking about the AWS Solutions Architect exam.
Oh, yeah, that's a big one.
It is.
For sure.
And we're not just dipping our toes in the water here.
Nope.
We've got a whole mountain of questions to climb, 54 to be exact. But don't worry, expert speaker is here to be our guide.
I'll do my best. I'll try and make sure you don't fall off any cliffs.
So listener, grab your virtual hiking boots
And your ice pick.
and get ready for a pretty intense AWS cram session.
Let's do it.
All right, first up is question 500.
Okay.
This one throws us right into the world of VPCs.
Right.
We've got two VPCs, one for management and one for production, connected by a VPN.
Standard setup.
Yeah, but we need to make sure this thing is rock solid.
Right.
We need to avoid a single point of failure. So what's the best way to back this thing up?
So it's like this, you wouldn't want a bridge held up by just one pillar, right?
No, I guess not.
If that one pillar fails, the whole bridge comes crashing down.
Makes sense.
Same with our VPCs. If we only have that single VPN connection and it fails, communication's cut off. So the solution is to add another VPN connection. That way, if one goes down, the other one's still there to keep things running.
Like a backup route.
Exactly. Redundancy is key in AWS architecture.
Okay, that makes sense. So on to question 501. Imagine a company, maybe it's Black Friday
Oh, boy.
or some other big sale,
Yeah.
and they're getting slammed with API requests.
Classic.
Their systems need to be able to handle that huge spike in traffic.
And then scale back down afterwards.
Exactly. So what's the AWS magic for this?
All right, so in this scenario, you'd want to bring in the dynamic duo of API Gateway and AWS Lambda. API Gateway is like the traffic cop directing all those incoming requests. And Lambda. Lambda's the workhorse. It processes all those requests and can automatically scale up to handle whatever load you throw at it.
So it grows and shrinks based on demand.
Right. And the best part is, you only pay for what you use. When the sale's over, Lambda scales back down, so you're not wasting money.
So it's like having a flexible workforce. You just hire more people when you need them.
Exactly.
Pretty smart. Okay, let's move on to question 502. This time, we've got a company that's generating huge reports, and it's really slowing down their main application. But it's not a CPU or memory problem. What's going on here?
So this sounds like a classic database bottleneck. Think of it this way. You've got a library, and everyone's trying to check out the same book at the same time.
So everyone's fighting over the same data.
Exactly. The solution is to make copies of that book, or, in this case, create read replicas of the database.
So you can pull the reports from the replica.
Exactly. That way, the reports don't slow down the main database.
Brilliant. Okay, question 503 is all about saving money.
Everyone loves that.
A company needs to run a really resource-intensive process for a week every month using 20 EC2 instances. What's the most cost-effective way to reserve those instances?
So it's a recurring event.
Every month, at the beginning of the month.
Got it. In that case, the answer is scheduled reserved instances.
Oh, I've heard of reserved instances, but what are scheduled reserved instances?
Think of it like booking a hotel room for the same week every month. You get a discount because you're committing in advance. It's the same with scheduled reserved instances. If you know exactly when you need those instances, you can reserve them ahead of time and save some serious cash.
It's like pre-booking your cloud resources. Smart move.
Definitely.
Okay, let's move on to question 504. This one's about storage.
Storage is fun.
It is. A company needs a storage solution for their employee home directories, and it needs to be resilient. We're talking automatic backups, disaster recovery, and tight access control linked to their Active Directory. What does AWS recommend for this?
For that specific scenario, Amazon FSx for Windows File Server is the perfect fit. Think of it as a supercharged, cloud-based file server designed specifically for Windows environments. You get fault tolerance with a multi-AZ setup, backups and recovery happen automatically, and it integrates seamlessly with Active Directory.
So it's like having a bulletproof file server that's always on.
Exactly.
Awesome. Now, question 505 is all about finding the right database.
One of my favorite topics.
A company has an application that faces customers, and it has these fluctuating read and write demands. They need database auditing, AWS managed scaling, and a recovery point objective of fewer than 5 hours. What's the winning strategy here?
All right, so we've got a couple of options here, both using DynamoDB.
Okay.
Option A combines DynamoDB with auto-scaling, on-demand backups, and CloudTrail for auditing.
Okay.
Option B also uses DynamoDB with auto-scaling and on-demand backups, but uses DynamoDB streams for auditing instead of CloudTrail.
Oh, interesting. So what's the difference?
The choice really comes down to how granular you need your auditing to be. It's kind of like choosing between two security cameras. One gives you a wide view.
The 30,000-foot view.
Right. And the other zooms in on specific areas. You pick the camera that suits your needs.
Makes sense. Okay, let's move on to question 506. This one is about application migration.
All right.
A company wants to move their old web application,
Mm-hmm.
the legacy kind, to AWS.
Yeah.
That includes the web tier, application tier, and a MySQL database. But they really don't want to manage servers.
Got it. So they want to go serverless.
Exactly. So what's the dream team of AWS services for a migration like this?
Okay, so for a smooth serverless migration, I'd recommend AWS Fargate for running the application without managing servers, and Amazon Elastic Container Service for orchestrating those containers.
So it's like having a self-driving car for your application. You just tell it where to go.
Yeah, you set the destination, and AWS handles the driving.
Sounds like a smooth ride.
Definitely.
Okay, question 5 by 7 puts data security front and center.
Rightfully so.
A company wants to make absolutely sure that no one unauthorized can access the sensitive data in their RDS instance. And this RDS instance is running Microsoft SQL Server.
Okay.
But here's the kicker. They even want to prevent their own IT staff from accessing the data.
Interesting. So how do we lock this down?
How do you lock it down?
Encryption is our hero here, and specifically, we're talking about Amazon RDS encryption using AWS Key Management Service, or KMS for short. Think of KMS like a super secure vault where you keep your encryption keys.
So the keys to the kingdom.
Exactly. By encrypting the data and managing those keys with KMS, you make sure that only authorized users with very specific permissions can even get a peek at that data.
So it's like a bank vault for your data with multiple layers of security to keep those unauthorized users out.
Right.
I like it. All right, in question 508, we're trying to optimize performance for Amazon Aurora.
Love Aurora.
That's a good one. So this company switched their e-commerce application over to Aurora,
Smart move.
but they're hitting a snag. When they run big reports, things slow down.
Hmm.
What's the most cost-effective way to give them a performance boost when they're running those reports?
Okay, so the answer here is to increase the provisioned IOPS on their Aurora instance. IOPS stands for Input-Output Operations per Second. Think of it like lanes on a highway. The more lanes you have,
The smoother the traffic flows.
exactly. By increasing IOPS, you give Aurora more bandwidth to handle those data-intensive reports without breaking a sweat.
So it's like widening the data highway so those big report trucks can get through.
That's a great analogy.
All right. Now for question 509, we're diving into IAM policies. We get this specific policy and we have to figure out what it actually does.
Okay, fun. Let's see it.
Can you break this one down for us?
Sure. So this policy controls access based on two things: the user's IP address and the location of the EC2 instance. It's like a key card that only works for certain doors in a building. In this case, the policy only allows users to terminate EC2 instances if they're in a specific region and are coming from a specific IP address. Anything else, and they're blocked.
So very specific permissions based on location and identity.
Yep.
Got it. Now, question 510 is about finding the right database again. This company is moving their on-premises application to AWS. They do a ton of database reading, and they need a solution that's more flexible and available.
Okay, sounds like they need to modernize a bit.
Yeah. Plus, their development team keeps making full copies of the database every 4 hours, which is causing some serious lag.
Yeah, that'll do it.
What's the solution here?
Okay, this sounds like a textbook case for Amazon RDS for SQL Server, set up with multi-AZ deployment and read replicas.
Read replicas.
Yeah, read replicas. Not only does RDS give you high availability and elasticity, but those read replicas are perfect for the dev team. They can use a replica for testing so they're not messing with the live production database.
So it's like a sandbox for the developers. They get to play without breaking anything important.
Exactly.
I like it. All right, question 511 is all about remote employees and secure file access.
A hot topic these days.
It is. So this company has an on-premises Windows file server, the old school kind.
Yep.
It's running out of space, and they need a solution that's secure and scalable,
Okay.
especially for sensitive files. What does AWS suggest?
Okay, so for this, the answer lies in migrating those files to Amazon S3 and using signed URLs and VPC endpoints. So first, you move everything to a private S3 bucket within a VPC. That keeps all the traffic nice and secure within the AWS network. Then you can generate these pre-signed URLs. They have expiration dates, and you give those to your employees. That gives them temporary, controlled access to specific files.
Ah, so it's like a time-limited access pass.
Precisely.
Very cool.
Right.
Okay, question 512 is all about preventing a hardware failure from taking down an entire application.
Yeah, that's never good.
So we've got a company that's using EC2 instances for a data-intensive application.
Okay.
And they need to make sure that groups of nodes aren't all running on the same hardware, just in case something goes wrong.
Right, so they need to spread things out. The solution here is to use a spread placement group.
A spread placement group?
What's
Yeah.
that? It's like assigning seats on a plane. You wouldn't want all the passengers from the same group clustered together, right?
No, in case the plane.
Exactly. Same idea here. A spread placement group ensures that your EC2 instances are spread across different underlying hardware. So if one piece of hardware fails, the others are still up and running.
So it's all about diversifying your risk.
Exactly.
Okay, that makes sense. Now, question 513 focuses on secure internet access.
Okay, let's hear it.
A company wants to give EC2 instances in a private subnet access to the internet so they can download updates and stuff like that.
Okay.
But they don't want those instances making any outbound connections, for security reasons.
Makes sense.
How do you set up that kind of one-way access?
It's like a one-way mirror, right? You can see out, but no one can see in.
Precisely.
Eh.
So how do we do it?
Okay, so you can achieve this by using an internet gateway and configuring the route table for that private subnet. The internet gateway will allow inbound traffic from the internet to reach those instances, but it won't allow the instances to initiate any outbound connections.
So it's a controlled entry point.
Exactly.
I like it. Okay, let's move on to question 514. This one is about global website hosting and doing it cost-effectively. A company wants to move their static website to AWS,
Makes sense.
and they want to make sure that it loads quickly for users all over the world.
So they need speed and global reach.
Yeah. What's the secret recipe for that?
Okay, the winning combo here is Amazon S3 and Amazon CloudFront.
Okay, I know about S3, but remind me about CloudFront.
Sure. So you store your website content in an S3 bucket, and you set it up for static website hosting. Then you set up a CloudFront distribution with that S3 bucket as the origin. Now, CloudFront has this awesome global network of edge locations, which basically means it caches your website content closer to your users all around the world.
Oh, that's
Yeah, that's how you get super fast loading times.
So it's like having a network of content delivery hubs around the world.
Precisely.
Okay, that's awesome. Let's switch gears and talk about security.
Love it.
Question 515 is all about protecting AWS accounts from cryptocurrency mining attacks.
Ah, those are nasty.
They are. So how do we stop them?
Amazon Guard Duty is the answer. It's like having a security guard constantly patrolling your AWS environment, watching out for anything suspicious. That includes those sneaky attempts to hijack your resources for crypto mining.
So it's like an AI-powered security system
Yeah.
that's constantly on the lookout for intruders.
Right? Always watching.
I like it. Now, in question 516, we're challenged to design a really tough web application. We're talking high availability, able to handle unpredictable traffic spikes.
Sounds like a fun challenge.
What's the architecture for a scenario like this?
Okay, so for this one, I'd recommend deploying Amazon EC2 instances in auto-scaling group behind an application load balancer. And you'll want to deploy this across multiple availability zones.
Okay, let's break that down a little bit. So what does the auto-scaling group do?
So the auto-scaling group is like the elastic band of your application. It can stretch to handle growth and then shrink back down when things quiet down.
And the application load balancer.
That's the traffic cop.
Hmm.
It makes sure that traffic is distributed evenly across all those EC2 instances.
I see.
And then by deploying across multiple availability zones, you're basically making sure your application is highly available and fault tolerant, even if one zone experiences an outage.
So it's like having a backup power grid.
Exactly.
Okay, let's move on to question 517, which is about backup and recovery.
Right.
A company needs to get rid of their old on-premises backup solution, the kind that takes up a whole server room,
I know the type.
and they want to move to an AWS solution. But they still need to be able to access their data locally.
Okay, so they want the best of both worlds.
Exactly. So what's the answer?
The answer here is AWS Storage Gateway. specifically the stored volume gateway configuration. Storage gateway is like a bridge between your on-premises environment and AWS storage services. With the stored volume gateway, you can keep your data local, but it's constantly being backed up to Amazon S3 in the background.
So it's like having a mirror image of your data in the cloud.
Exactly.
Cool. All right, question 518 is about controlling access to premium content.
Interesting. Let's hear it.
A company wants users to be able to buy access to content. This content is stored in an S3 bucket,
Okay.
and they should have 14 days to download it once they've paid.
Right.
What's the easiest way to implement something like that?
The most straightforward way is to use an Amazon CloudFront distribution with an S3 origin and then leverage signed URLs.
Remind me, how do signed URLs work again?
Sure. So your application can generate these pre-signed URLs that expire after a certain amount of time, in this case, 14 days. Users who pay get these special URLs, and that gives them temporary access to download the content.
So it's like a time-limited backstage pass to the premium content vault.
You got it.
Okay, question 519 is about sharing a big log file with an application vendor.
Oh, those can be huge.
The log file is stored in S3, and they only need access for a short time.
Makes sense.
What's the most secure way to handle this?
Okay, the best way is to generate a pre-signed URL with an expiration date. This gives the vendor temporary time-bound access to download the log file. The key here is that you don't have to expose your AWS credentials or make any permanent changes to your S3 bucket permissions.
So it's like sending a self-destructing message. The vendor gets access for a specific time, and then poof, it's gone.
Right.
Okay, back to IAM policies with question 520.
All right, fire away.
We've got another policy to decode.
Let's do it.
What's the net effect of this one?
Okay, so this particular policy is a conditional deny statement. Basically, it says if you want to upload objects to S3, you got to have multi-factor authentication enabled.
MFA. Got it.
Yeah, any other action on S3 is a no-go if MFA isn't active. It's a security measure to make sure that only properly authenticated users are doing stuff on S3.
So MFA is the key to unlocking the S3 door.
That's a great way to put it.
Okay, I like it. Question 521 is about database migration and high availability. We've got an online learning company that wants to migrate their PostgreSQL database to AWS.
Makes sense.
They need a multi-region solution for redundancy, of course, with high availability and as little operational overhead as possible.
So low maintenance, high availability.
Exactly. What's the recommended approach here?
All right, so the best solution here is to migrate that PostgreSQL database to an Amazon RDS for PostgreSQL DB instance.
RDS.
Yeah, and then you create a read replica in another region.
I see.
RDS handles all the database management for you, which minimizes overhead. And having that cross-region replication means that your data is safe and sound, even if one entire region goes down.
So it's like having a backup campus for your database, ready to take over if the main one goes offline.
Exactly. Always be prepared.
Okay. Question 522 is all about making sure you can always write to your database. Always. A multi-tier e-commerce application is using an Amazon Aurora MySQL DB cluster. They have a writer and reader in a multi-AZ environment.
Okay. Standard setup.
But they need continuous write availability even during failover. So if something goes wrong,
Once instance fails.
they need to be able to keep writing to the database without any interruption. How do they do that?
Okay, for that, they need to migrate their database tier to an Aurora multi-master cluster.
What's that?
So a multi-master cluster lets you have multiple writer instances. That way, even if one writer goes down, the others can pick up the slack and handle all those write operations without skipping a beat.
So it's like having multiple pilots in a cockpit just in case one of them needs to take a break.
Exactly. Redundancy is king.
Okay, question 523 is a storage challenge. We've got a photo hosting service
Sounds fun.
that needs a cost-effective way to store all those photos.
Right, and there are a lot of photos.
A lot. And of course, some photos are super popular and get viewed all the time, while others are only viewed for a little bit.
So they have varying popularity.
Yeah. They also need to store metadata for each photo and allow uploads up to 20 millibs in size. What's the solution here?
Okay, so this is where Amazon S3 intelligent tiering comes in. It's a really cool feature that automatically moves objects between different S3 storage classes based on how often they're accessed.
So it optimizes storage costs.
Exactly. And for the metadata, DynamoDB is a great choice. It gives you low latency access and can handle just about any workload you throw at it.
So it's like having a smart storage system that automatically knows where to put everything based on how often it's used.
Exactly.
Okay, I like it. Question 524 is about migrating a big on-premises Microsoft SharePoint deployment to AWS. We're talking Windows shared file storage, high availability, and Active Directory integration.
Right, so we need something that plays nicely with Windows.
Yeah. What does AWS recommend for this?
Okay, hands down, Amazon FSx for Windows File Server is the way to go. It's a fully managed service, and it's specifically built to support those Windows-based workloads like SharePoint. You get high availability, easy integration with Active Directory, and the scalability you need to handle large deployments.
So it's like having a cloud-based file server that's custom built for SharePoint.
Exactly.
Pretty slick. Now, question 525 is about secure database authentication. A company wants to allow its EC2 instances to authenticate to an Aurora database,
Okay.
but they don't want to use static credentials.
Right, because those can be a security risk.
Yeah. So what's the solution here?
The answer lies in IAM roles and instance profiles.
Remind me how those work again.
Sure. So you create an IAM role,
Yeah.
and you give it the permissions that are needed to access that Aurora database. Then you create an instance profile and attach it to your EC2 instances. That instance profile uses the IAM role you just created.
I see.
And by doing that, the EC2 instances inherit the permissions of that IAM role. So there's no need to store any credentials on the instances themselves.
So it's like giving the EC2 instances a temporary security badge.
Precisely. They get the access they need, but it's all temporary and controlled.
Awesome. Okay, question 526 is about keeping those CloudFront costs down.
Everyone loves saving money.
We do. So this company is hosting a static website in an S3 bucket behind CloudFront,
Standard setup.
and they're looking to save a few bucks.
Makes sense. CloudFront can get a little pricey if you're not careful.
Yeah. So what's a simple way to reduce their costs?
One easy way is to adjust the CloudFront price class.
Oh, interesting. Tell me more about that.
Sure. You can actually configure CloudFront to only include the specific locations or countries that you're serving.
I see.
So you're tailoring your CloudFront distribution to your actual user base, which means you're not paying for traffic from regions where you don't have any users.
So it's like targeted advertising for your content delivery.
That's a great way to put it.
All right, let's move on to question 527. This one's about encryption.
Love it.
A company has an RDS MySQL database, but there is a problem.
What is it?
They set it up without encryption.
Oh.
Yeah, not ideal. So now they need to encrypt this existing data. How do they go about doing that?
All right, so the process involves creating an encrypted copy of the RDS snapshot. First, they take a snapshot of the unencrypted RDS instance. Then, they create an encrypted copy of that snapshot, and they'll use KMS for that. Finally, they create a brand new RDS instance from that encrypted snapshot.
So it's like putting a lockbox around your existing data.
Exactly.
Pretty slick. All right, question 528 is about setting up secure communication between a Lambda function and an on-premises database.
Sounds challenging.
It is. So a development team needs to allow a Lambda function to access a database.
Okay,
This database is in a private subnet within their on-premises data center.
that's behind their firewall.
Yeah. How do they set up a secure connection for this?
Okay, so the solution is to configure that Lambda function to run inside their VPC. And of course, you'll need to set up the appropriate security groups. This setup allows the Lambda function to communicate directly with resources within that VPC, including the database and the private subnet.
So it's like giving the Lambda function a special pass to enter that secure network zone.
Exactly.
Okay, question 529 tackles a common availability issue. A company is using API, Gateway, Lambda, and DynamoDB.
A solid combo.
It is, but they're still having availability problems. They're losing requests even though they've provisioned plenty of the DynamoDB throughput.
Interesting. So what's the catch?
Its question is, how do you improve availability without impacting the users who are already on the system?
Okay, I see. So in this case, you want to implement DynamoDB Accelerator or DAX with Lambda.
Remind me, what does DAX do?
So DAX acts as a high-speed cache for DynamoDB. Basically, it absorbs all those write requests and prevents them from overwhelming the database. Lambda can then talk to DAX instead of directly writing to DynamoDB.
It's like a shock absorber for your database.
That's a great analogy.
Okay, question 530 is about optimizing costs and resource management.
Always a good thing.
It is. So this company is worried about over-provisioning its infrastructure. They're using EC2 auto-scaling, but they're concerned about the front end of their three-tier application.
Okay, so they want to make sure they're not paying for resources they're not using.
Exactly. How can a solutions architect optimize those costs without sacrificing performance?
All right, so the solution is to take advantage of the suspend and resume feature of auto-scaling. This lets you temporarily hit pause on scaling activities during those times when you know demand will be low.
So if you know that traffic dips at night, for instance.
You can suspend auto-scaling during those hours.
So it's like putting your auto-scaling group on a timer.
Yeah.
You let it rest and recharge when it's not needed.
Exactly. Saves energy, saves money.
I like it. All right, let's dive into question 531, which is all about network security and access control.
One of my favorite topics.
We've got a company that's deploying an application with 2 layers, a web layer in a public subnet, and a MySQL database in a private subnet.
Okay, classic setup.
And they have some pretty strict security requirements.
Yeah.
They want SSL-only access for their servers, restricted database access, and they want to block traffic from a specific range of IP addresses.
Okay, so they're serious about security.
Yeah, they are. What steps should they take to make sure they meet all these requirements?
All right, so for a scenario like this, they need to implement a multi-layered security approach.
Okay, take me through it.
First, they need to configure the database security group.
So only certain traffic can get to the database.
Right. They need to allow inbound traffic only on the MySQL port, that's port 3306.
Okay.
And they should restrict the source to the security group used by the web servers. That makes sure that only the web servers can talk to the database.
Makes sense. What's next?
Second, they need to set up a web server security group. This one allows inbound HTTPS traffic on port 443 from anywhere. That lets people access the web servers securely.
Okay, and finally.
Finally, they need to add some network ACL rules, both inbound and outbound deny rules for that specific IP range they want to block. These rules should be applied to both the public and private subnets.
So it's like setting up a multi-layered security system. You've got checkpoints, restricted access zones, and a watchful eye on all traffic.
That's a great analogy.
All right, we're making great progress here. Let's move on to question 532. This one's about managing access between different AWS accounts. So we've got a company that has separate accounts for production and development.
Okay, standard practice.
Makes sense. Now, they want to give limited access to the production account, but only to senior developers.
Okay.
This is just for the alpha phase, early testing.
Right.
And they might want to open it up to more developers later on during the beta phase.
So they need a flexible solution.
Yeah. What's the best way to manage this kind of evolving access?
Okay, so the recommended approach here is to create an IAM group in that production account. Then you add that group as a principal in the trust policy for the production account. This lets you define the permissions for the group and control who can access that production account. Initially, you would only add those senior developers to this group. Then, when it's time for beta testing, you just add more developers to the group.
So it's like a VIP list for the production account.
Exactly. You control who gets in and who doesn't.
Okay, I like it.
Yeah.
Question 533 is all about logging and auditing.
Crucial for security.
It is. So this company needs to keep track of every single access to a specific S3 bucket. This bucket contains sensitive financial reports.
High stakes.
Yeah, and they need to be able to detect any modifications to those.
Yeah. Any changes to those log files should raise a red flag.
Exactly. So what solution can they implement to get that level of monitoring and security?
Okay, so the solution here is to use AWS CloudTrail.
Okay, I know a little about CloudTrail. What do we do with it?
So you create a new CloudTrail trail, and you configure it to log all those read and write data events for that S3 bucket. You know, the one with those sensitive financial reports.
Right.
And you should also enable log file validation. CloudTrail uses digital signatures to make sure that those log files haven't been tampered with.
So it's like having a tamper-proof security camera.
Exactly.
Okay, I like it. All right, let's tackle question 534, which is all about disaster recovery. We've got a company with an Aurora MySQL DB cluster.
Okay.
It's in the U.S. East 1 region.
All right.
And they need a disaster recovery plan, just in case.
Always good to have a plan B.
Yeah. So they want to be able to fail over to the U.S. West 2 region if something goes wrong.
Okay.
And they have an RTO of 15 minutes.
That's pretty tight.
It is. So what steps should they take to make this happen?
Yeah. Okay, so they should use snapshots and Lambda functions, and they can orchestrate all of this with Amazon Event Bridge. First, you take a snapshot of the DB cluster in US East 1. Then, you set up an Event Bridge rule that triggers a Lambda function when certain events occur, like a database failure, for instance.
I see.
That Lambda function then copies the snapshot over to US West 2 and restores it to a new DB cluster in that region.
So it's like having an emergency kit for your database.
Exactly. It's ready to go at a moment's notice.
Love it. Now, question 535 asks us to design a system for tracking package deliveries.
All right, so we're in the logistics business now.
We are. So this system has to handle a huge range of workloads. Could be a few packages or millions of packages.
So it needs to be scalable.
Very scalable. Users need to be able to access tracking information quickly,
Low latency.
and they need to be able to search by different criteria like tracking ID, customer ID, order ID, you name it. What's the best solution for this?
Okay, for that scenario, I'd go with DynamoDB, and I'd use global secondary indexes and TTL. DynamoDB can handle huge volumes of data with low latency, which is perfect for tracking packages in real time. Those global secondary indexes make it easy to search by all those different criteria.
Right.
And TTL, which stands for time to live, lets you automatically delete old tracking data that's no longer needed.
So it's like having a super efficient logistics control center.
Exactly.
You can track every package, answer questions instantly, and it cleans up after itself.
Love it.
All right, let's move on to question 536. This one's about managing access to S3 buckets within an AWS organization.
Okay, so we're dealing with multiple AWS accounts.
Yeah. A company wants to restrict access to an S3 bucket containing project reports.
Okay.
Only users from accounts within their organization should be able to access this bucket. What's the simplest way to set that up?
The simplest way is to use IAM tags and bucket policies. So you tag each user who needs access with a specific tag, maybe something like project access. Then you modify the bucket policy to include a condition that checks for that tag. That ensures that only users with the right tag can get into that bucket.
So it's like a digital badge system for your organization.
Exactly. Only those with the correct credentials get access.
I like it. Okay, question 537 is about keeping application traffic secure. A company needs to make sure that the traffic between their EC2 hosted application and their S3 storage never goes out over the public internet.
So they want to keep it all internal.
Exactly. How do they set up that secure communication channel?
VPC endpoints are the answer here. They allow you to create a private connection between your VPC and those supported AWS services like S3.
So the traffic never leaves the AWS network.
Exactly. It's much more secure that way.
So it's like having a dedicated private highway for your data.
That's a great way to visualize it.
All right, question 538 brings us back to email.
Email. It never goes away.
It doesn't. So this e-commerce company is growing like crazy, which means more users, more orders, more everything.
More emails.
Exactly. They need to make sure their email system is up to the task marketing emails, order confirmations, all that good stuff.
Right, they need reliability and efficiency.
Exactly. What should they do?
Okay, for this, I'd recommend using Amazon Simple Email Service, or SCS.
Okay, so they're not sending emails directly from their web servers anymore.
Right. They should configure their application to send those emails through SCS. SCS is designed specifically to handle the complexities of email delivery at scale.
So it's like having a dedicated postal service for your application.
Precisely. Fast, reliable, and built for volume.
Okay, question 539 presents a migration challenge. A company needs to move their document management workload over to AWS.
Sounds like a big job.
It is. So we're talking 7 TB of contract documents stored on a shared file system. There's an external database for tracking all these documents. And the documents are mostly accessed for reference, if someone needs to check something from a while back.
Got it.
And of course, the web servers running on EC2 instances in an auto-scaling group need to be able to access these documents.
So what's the most cost-effective way to move all of this over to AWS?
Yeah, what's the best solution?
All right, so for this, the most cost-effective approach is to use AWS Transfer for SFTP with an Amazon S3 bucket.
Okay, let's break that down. So what's AWS Transfer for SFTP?
It's a fully managed service that lets you set up an SFTP server endpoint. You point that endpoint to an S3 bucket.
Okay.
Then you configure your EC2 instances to connect to that SFTP server.
So it's like having a secure file transfer service in the cloud integrated with your S3 storage.
Exactly. And S3 is a great choice for storing those documents because it's super durable and cost-effective.
Okay, let's move on to question 540, which is about EC2 auto-scaling and batch processing. So a solutions architect notices that a nightly batch processing job is taking a whole hour to reach the desired EC2 capacity, even though the peak capacity is the same every night.
Interesting. Sounds like we can optimize something there.
Yeah. So what can the architect do to get to the desired capacity more quickly and save some money in the process?
All right, so the solution here is to move away from reactive scaling and implement scheduled scaling instead.
So what's the difference?
With reactive scaling, auto-scaling waits for certain triggers like high CPU utilization before adding or removing instances. But with scheduled scaling, you can be proactive and tell auto-scaling to scale up that group just before the batch job starts.
Ah, I see. So the resources are already there and ready to go.
Exactly. No more waiting around.
So it's like setting an alarm clock for your auto-scaling group.
That's a great analogy.
All right, question 541 is all about achieving a super low RPO for a PostgreSQL database.
Okay, so we're talking about minimizing data loss in a disaster scenario.
Precisely. This company wants an RPO of less than 1 second for their production database. 1 second.
Wow. That's pretty demanding.
It is. So what's the solution here?
Okay, to achieve that level of resilience, you need to combine a multi-AZ deployment with change data capture.
Okay, so what does that mean?
You configure the PostgreSQL DB instance for multi-AZ deployment. That gives you high availability and automatic failover. Then you set up some DMS, which stands for Database Migration Service CDC tasks. CDC stands for Change Data Capture. Those CDC tasks will capture and replicate any database changes in real time.
So it's like having a real-time backup system for your database.
Exactly. You're minimizing data loss to a fraction of a second.
That's incredible. Okay, question 542 is about understanding S3 storage costs. A company is using S3 for their data, and they're noticing a discrepancy. The storage size reported in the AWS Management Console doesn't match up with the storage costs they're actually being charged.
Interesting. That's definitely something to look into.
Yeah, so what could be causing this difference?
Okay, so a couple of things could be happening. First, if versioning is enabled on the S3 bucket, every single version of an object counts towards that total storage size.
Ah, so even old versions are taking up space.
Yep. And second, files that are stored with deduplication enabled might not be reflected accurately in the console's storage size. Even though deduplication reduces how much physical storage you're using, it might not show up correctly in the console.
So it's like having hidden compartments in your storage unit.
That's a great way to put it. The space is being used, but it might not be obvious.
Okay, that makes sense. Question 543 is about performance optimization for a 3-tier web application.
All right, let's hear it.
The application is having some trouble during peak times. Order confirmations are taking a long time to process, and that's causing delays for customers.
Not good.
Nope. What's the most cost-effective way to speed up those processing times?
Okay, the solution here is to use EC2 auto-scaling to scale out those middle-tier instances based on the SQS queue depth.
Okay, let's break that down a little. So what's SQS?
SQS stands for Simple Queue Service. It's a messaging queue that lets you decouple different parts of your application.
Okay.
So by monitoring how many messages are in that SQS queue, you can trigger auto-scaling to add more middle-tier instances when the queue starts to fill up.
So it's like having a flexible assembly line that adds more workers when the orders start piling up.
Exactly.
Okay, let's move on to question 544. This one is about global routing and on-premises hosting.
All right, so we're spanning the cloud and the physical world.
We are. So a company needs to route traffic for their application to on-premises servers.
Okay.
These servers are in different regions around the world.
So global reach is important.
It is. And the application uses UDP communication. They need to make sure that performance and availability are top-notch.
So low latency and no downtime.
Exactly. What's the recommended solution for this?
All right, so this one's a bit more complex. The company should combine network load balancers, Route 53 latency-based routing, and CloudFront.
Okay, that sounds like a lot. Let's break it down.
Sure. So first, they configure NLBs. Those are network load balancers in each AWS region. These NLBs point to their on-premises endpoints.
Okay.
Then they create a Route 53 latency-based record that points to those NLBs. This record will automatically direct traffic to the closest region based on the user's location.
So users in Europe are directed to the European servers.
Exactly. And finally, they use that latency-based record as the origin for a CloudFront distribution.
So it's like having a global network of traffic directors,
That's a great analogy.
guiding users to the closest on-premises server with the best performance.
Precisely.
Awesome. All right, question 545 is about boosting VPN throughput.
Okay, let's hear it.
A company is using site-to-site VPN connections for secure connectivity to AWS.
Standard setup.
Yeah. But their VPN connection is slowing down because of increased traffic.
Makes sense. More traffic means more congestion.
Exactly. What can they do to get things moving faster?
The solution here is to implement multiple customer gateways for the same network.
So instead of having one VPN connection, they have multiple.
Precisely. By creating multiple VPN connections, you distribute that traffic load and increase your overall throughput.
So it's like adding more lanes to your VPN tunnel.
That's a great analogy.
Okay, question 546 is about network security and isolation within a VPC. A company needs to design a multi-subnet VPC architecture.
All right, let's get architectural.
Only instances in the private subnet should be allowed to access a database.
Okay, so we need to lock down that database access.
Exactly. How do they achieve that level of isolation?
Security groups are the answer. They create a security group for that database, and they configure its inbound rules to deny traffic from the security group that's being used by instances in the public subnet.
So it's like setting up a firewall around the database.
Precisely. You control which network segments can get in and which ones are blocked.
I like it. Question 547 is about improving the resilience and global reach of a static website. Currently, this website is hosted in an on-premises data center.
Okay, so they're looking to move to the cloud.
Exactly. What's the best way to achieve those goals?
Okay, they should use Amazon Route 53 to distribute the load across multiple CloudFront distributions.
Okay.
And each of these CloudFront distributions serves a different AWS region globally.
So we're talking about a global content delivery network.
Exactly. Route 53's intelligent routing capabilities will direct users to the closest and most responsive CloudFront distribution. And CloudFront's global network of edge locations will cache that website content closer to those users.
So it's like creating a network of mirrors for your website.
Love that analogy.
Users around the world see the most up-to-date content with the fastest possible loading times.
Precisely.
Okay, question 548 is about optimizing data transfer costs for a batch processing application. The application runs on EC2 instances, and it processes data from S3 and then stores the output in another S3 bucket.
All right, so we're moving data around.
We are. What can the solutions architect do to minimize those data transfer costs?
The simplest solution here is to make sure that all those EC2 instances are in the same AWS region as those S3 buckets. Data transfer within the same region is free, so this eliminates any inter-region data transfer costs.
So it's like keeping your ingredients and cooking equipment in the same kitchen.
Exactly. Everything is readily accessible, no need for long-distance transport.
Love it. All right, question 549 is all about protecting those important documents stored in an S3 bucket.
Okay, data protection is crucial.
It is. The company wants to prevent accidental deletion and make sure they have version control in place.
Makes sense.
But they still want their users to be able to download, modify, and upload documents.
So they need a balance of control and flexibility.
Exactly. What's the solution here?
The best approach is to enable both versioning and MFA delete on that S3 bucket.
Remind me what those do.
Sure, versioning keeps a copy of every version of a document, so you can always roll back to a previous version if you need to. And MFA delete requires multi-factor authentication to permanently delete any objects from that bucket.
So it's like having a safety net and a security gate for your documents.
Precisely.
I like it. Okay, question 550 is about storage optimization. A company needs to store critical business data for 4 years.
Okay, so long-term storage.
Yeah. They access the data frequently in the first 30 days,
Okay.
and then it's infrequent access after that.
So they need a tiered storage solution.
Exactly. What's the most cost-effective way to handle this?
All right, this is a great use case for S3 lifecycle policies.
Oh, lifecycle policies. Tell me more about those.
Sure. So you can set up a lifecycle policy to automatically transition those files from S3 standard to S3 standard infrequent access or S3 standard IA after 30 days.
Okay.
And then you can set it to delete those files after 4 years. S3 standard is best for frequently accessed data because it's got the lowest latency. But S3 standard IA is a cheaper option for data that you access less often.
So it's like having a self-sorting archive system.
That's a great way to think about it.
The most recent stuff is readily available, and then older files are tucked away in a cheaper storage tier.
Exactly.
All right, question 551 is about speeding up uploads and downloads for video files.
Okay, video is always a bandwidth hog.
It is. So this company wants to offer faster video transfer speeds to their paying customers.
So it's a premium feature.
Yeah. They've got a subscription service, and they want to give those subscribers a better experience.
Makes sense. What's the best way to do that?
Yeah.
Okay, they should use Amazon CloudFront with their S3 bucket as the origin, and they should adjust their application so that subscribers use the CloudFront URL.
Okay, so CloudFront is involved. How does that help?
So CloudFront is a content delivery network, or CDN. It has servers all over the world, which means it can cache those video files closer to users, making downloads much faster.
So it's like having a local copy of the video, even if it's actually stored in an S3 bucket somewhere else.
Exactly. And for uploads, CloudFront can also accelerate the transfer of those large files to S3.
So it's like having a high-speed express lane for your video traffic reserved for those premium subscribers. Okay, question 552 is about adding an extra layer of security for sensitive information in a CloudFront distribution.
Okay, sounds like we need to lock things down even further.
We do. The application already uses HTTPS.
So the connection is encrypted.
Yeah, but they want to protect that data at every level, from the client all the way to the server.
Right, end-to-end security.
And they want to restrict access to specific applications. What's the recommended solution here?
For this, the answer is to use CloudFront signed URLs.
Signed URLs.
Yep. Signed URLs let you create these time-limited URLs that have specific permissions built in. That means you can grant access to the content in your CloudFront distribution only to those authorized users or applications.
So it's like adding a digital signature to your content.
Precisely. It verifies the authenticity and makes sure that only authorized parties can access the data.
Okay, question 5533 takes us to a company with an application running in a branch office.
Right.
They've got limited infrastructure at this branch office.
So they need a simple, efficient solution.
Exactly. The application data is stored on an NFS volume.
Okay.
And they need to back it up off-site every day.
Right. Disaster recovery is crucial.
It is. So what's the recommended approach here?
Okay, for this, I'd recommend an AWS storage gateway file gateway hardware appliance.
Okay, what's that?
It's a physical device that you install on premises. It replicates the data from that NFS volume to Amazon S3.
So it's like having a dedicated courier service for your data.
Precisely. It securely transports your data to the cloud for safekeeping.
Love it. Now, question 5554 is about protecting a web application from those nasty HTTP flood attacks.
Those can be brutal.
They can. So we've got a financial company that's hosting its web application on AWS.
Okay, high stakes for sure.
They want to make absolutely sure that these attacks can't take down their application. What's the solution here?
Okay, so the recommended approach is to use Amazon CloudWatch metrics to monitor how many requests are coming in for that application.
So watch for suspicious spikes in traffic.
Exactly, and then you set up alerts for when the rate exceeds a certain threshold. That allows for early detection and gives you time to take action before things get out of control.
So it's like a flood warning system for your application.
That's a great way to put it. It alerts you to potential threats before they cause any serious damage.
All right, let's move on to question 5555, which is all about optimizing resource utilization and saving money. We've got an application that runs on EC2 instances. It gathers data from users, processes it, and then sends it off to S3 for storage.
Okay. Standard data pipeline.
Yeah. But the problem is that those EC2 instances are often sitting idle. They're not doing anything.
So they're wasting money.
Exactly.
Yeah.
What's a more efficient way to handle this?
Okay, so I'd recommend redesigning that application using an event-driven architecture with Amazon SQS and AWS Lambda.
Okay, so we're ditching the always-on EC2 instances.
Right. Instead, you use SQS to queue up all that incoming data.
Okay.
And then you trigger Lambda functions to process the data as it arrives.
So it's like having an on-demand data processing team. They only show up when there's actual work to be done.
Exactly.
Very efficient. Okay, question 556 is all about security best practices for web applications. This application is hosted on EC2 instances behind an application load balancer, or ALB.
Right.
And this company has strict security requirements. They want protection against all the bad stuff. Malicious internet activity, common vulnerabilities, you name it.
So they need a strong defense.
What's the solution?
Okay, so they should use AWS WAF, that's Web Application Firewall, and they should deploy the appropriate managed rule set for that ALB.
Remind me, what does WAF do?
WAF filters out all that nasty traffic and blocks any known attack patterns. And by deploying a managed rule set, they're basically tapping into AWS's expertise in mitigating web application threats.
So it's like having a security guard stationed at the entrance to your application.
Exactly. The guard screens visitors and makes sure only the good guys get in.
I like it. Okay, question 557 is about connecting to S3 buckets securely, but without going over the public internet.
So we need a private pathway.
They do. What's the recommended solution for achieving this?
The answer here is to configure a VPC gateway endpoint for Amazon S3.
A VPC gateway endpoint.
Yep. This lets you set up private communication between your VPC and S3. All that traffic stays within the AWS network, which means it's much more secure.
So it's like having a secret tunnel between your application and your S3 bucket.
Precisely. Keeps those prying eyes out.
Okay, question 558 focuses on application health and traffic redirection. We've got an online gaming platform, very latency sensitive, of course.
Gamers hate lag.
They do. So this application runs on EC2 instances in auto-scaling groups behind ALBs.
Okay.
And it's deployed in every AWS region.
So global reach.
Yeah, they want to make sure that gamers everywhere have a great experience.
Yep.
What's the solution for achieving both high availability and low latency?
Okay, for this, I'd recommend using Amazon Route 53 health checks together with your ALBs and auto-scaling groups.
Health checks.
Yeah, so Route 53 health checks are constantly pinging your application endpoints, making sure everything is working properly. And if they detect any problems, they automatically update your DNS records to redirect traffic to those healthy instances.
So it's like having a network of traffic controllers.
Exactly. They're constantly assessing the health of your game servers and making sure that traffic is flowing to the best performing ones.
Okay, question 559 is back to security best practices for a static website.
Security is a never-ending battle.
It is. So this website is hosted in an S3 bucket behind CloudFront.
Standard setup.
The company's security policy states that all traffic to the website has to be inspected by AWS WAF.
Got it.
And they want to restrict access to specific IP ranges just like they do with their EC2 instances.
Right, so they want granular control over who can access the website.
Exactly. What steps should they take to achieve this?
Okay, for this, they need to use Origin Access Identities, or OAIs, and AWS WAF.
OAIs.
So first, they create an OAI and associate it with the CloudFront distribution. Then they change the S3 bucket policy to allow only the OAI to read the objects in the bucket.
Okay, so only CloudFront can access the S3 bucket.
Exactly. Second, they create a DWAF web ACO that includes the same IP restrictions as their EC2 security group, and they associate this web ACL with the CloudFront distribution.
So it's like a two-factor authentication system for your website.
That's a great way to put it.
You're verifying the identity of the requester with the OAI, and then you're checking their credentials, their IP address in this case, with WAF.
Precisely.
All right, let's move on to question 560. This one is about preventing direct access to an S3 bucket.
Okay, so we need to close off any backdoors.
We do. This company is using an S3 bucket for their file sharing application.
Right.
They want all access to go through their CloudFront distribution.
Makes sense for security and performance.
Yeah. So how do they make sure users can't bypass CloudFront and access those files directly using the S3 URL?
All right, so the solution here is to create an S3 bucket policy that explicitly denies all access except from the CloudFront distribution.
Okay, how do you do that?
You specify the CloudFront distribution's Origin Access Identity, that's the OAI, as the only allowed principal in the bucket policy.
So it's like having a bouncer at the door of your S3 bucket.
Love it.
Only those with a valid CloudFront pass can get in.
Exactly.
Okay, question 561 is about managing VPC flow logs.
Okay, so we're talking about network traffic logs.
We are. The security team needs to keep these logs for a specific period of time.
Makes sense for auditing and analysis.
Yeah, they need to be able to access the logs frequently for the first 90 days.
Okay.
And then they only need to access them occasionally after that.
Mm-hmm.
What's the recommended solution for configuring these logs?
Okay, for this, they should use Amazon S3 as the target for those flow logs. And then they should implement an S3 lifecycle policy.
Okay, remind me how lifecycle policies work.
Sure. So first, they configure VPC flow logs to send those logs to an S3 bucket. Then they create an S3 lifecycle policy that automatically moves those logs to S3 standard IA after 90 days.
Ah, so it's like an automatic archiving system. Older logs are moved to a cheaper storage tier.
Exactly. You're saving money without sacrificing data retention.
I like it. Okay, question 562 is about containerized applications and simplifying infrastructure management.
Containers are all the rage these days.
They are. So this company wants to run their critical application in containers.
Okay.
They want scalability and availability.
Right. The benefits of containers.
But they don't want to spend all their time managing the underlying infrastructure.
Got it. So they want to focus on their application, not the servers.
Exactly. What's the recommended solution for this?
Okay. For that, the company should use Amazon ECS on AWS Fargate.
ECS and Fargate, got it. Remind me what those do again.
Sure. ECS provides container orchestration, which means it handles all the deployment, scaling, and management of those containers. And Fargate is the magic sauce that handles the underlying infrastructure. You don't have to worry about provisioning servers or managing clusters.
So it's like having a fully managed apartment building for your containers.
That's a great analogy. All the amenities and maintenance are taken care of.
All right, question 563 is about encrypting EDS volumes.
Encryption is always a good idea.
It is. So it's got some unencrypted EBS snapshots.
Uh-oh.
Yeah, not ideal. And we need to create new EBS volumes from those snapshots, but we want to make sure those new volumes are encrypted. What do we do?
Okay, so when you create that new EBS volume, you just specify a KMS customer master key or CMK for encryption.
So it's like making a secure copy of an unprotected document.
Precisely.
Okay, let's move on to question 564, which is back to security best practices for a static website. This website is hosted in an S3 bucket behind CloudFront, and the company's security policy states that all traffic has to be inspected by AWS WAF.
Okay, so no exceptions.
How can the solutions architect meet this requirement?
All right, so they should enable AWS WAF on that CloudFront distribution.
Okay.
And they need to configure CloudFront and S3 to use an origin access identity. That's the OAI. The OAI restricts access to that S3 bucket, which means all traffic has to go through CloudFront.
And that's where WAF is waiting to inspect it.
Exactly.
So it's like having a security checkpoint at the entrance to your website.
Love it. Every visitor gets screened.
Okay, question 565 is about database performance, and
Reporting.
it is. We've got a web application that's using an RDS PostgreSQL DB instance.
Okay.
And during peak reporting periods, the accountants run these huge queries.
Ah, yeah, that can definitely impact performance.
Yeah, and it's slowing down the application for everyone else.
Not good. So how do we fix it?
What's the recommended solution to make sure those reports don't impact the application's performance?
Okay, the solution here is to create a read replica and send all that reporting traffic to the replica.
So the reports aren't running on the main database anymore.
Exactly. That way, those big queries don't slow down the primary database instance, and the web application stays nice and responsive for everyone else.
So it's like having a dedicated research library,
Yeah.
separate from the main library, so the researchers don't disturb everyone else.
That's a great analogy.
Okay, let's move on to question 566. This one is about video processing.
Mine's a fun one.
It is. So this company has a two-tiered video conversation application.
Okay.
They've got a free tier and a paid tier.
Standard setup for a lot of apps these days.
It is. And for the paid tier, they want to convert those users' videos first. Give them priority processing.
Right, so the paid users get a better experience.
Exactly. What's the most cost-effective way to implement this kind of tiered processing?
Okay, I'd recommend using 2 standard SQS queues.
2 queues, okay.
One for each tier, free and paid. Paid tier videos get sent to the paid tier queue, which has a higher priority.
Okay.
And the free tier videos go to the free tier queue, which has a lower priority.
So it's like having a priority boarding lane for your paid users. Their videos get on the processing flight first, but you're still taking care of everyone in economy class.
Precisely.
Okay, question 567 is about building a messaging system for microservices using SQS and SNS.
Okay, so we're diving into the world of distributed systems.
We are. This company is building an online marketplace application,
All right.
and they want to make sure that when a customer places an order, a few things happen. They want to send an email confirmation,
Okay.
and they also want to trigger an event that kicks off the order processing workflow.
Right, so 2 things happening in parallel.
Exactly. And when an order is canceled, they want to send a cancellation email and trigger a cancellation processing event.
So we need a system that can handle these parallel workflows.
Exactly. How can they do this using SQS and SNS?
All right, so they should create 2 SQS queues.
Okay.
One queue is dedicated to email notifications, and the other is for order processing.
Okay.
Then they publish those order events to both queues simultaneously.
At the same time,
Yep. And that's where SNS comes in. When a new order or cancellation comes in, an SNS message triggers both the email notification microservice and the order processing microservice.
so it's like a 2-track delivery system for your order events. Notifications and processing happen side by side.
Precisely.
All right, question 568 is about giving EC2 instances access to a DynamoDB table, but only the access they absolutely need.
Least privilege, that's the key.
It is. So what's the recommended approach for achieving this?
Okay, this is another scenario where IAM roles and instance profiles are the perfect solution. You create an IAM role that has only the permissions needed to access that specific DynamoDB table.
Okay.
Then you create an instance profile and associate that role with your EC2 instances.
So it's like those temporary security badges again.
Exactly. The EC2 instances get just enough access to do their job and no more.
Okay, let's tackle question 569, which is all about consistent tagging.
Tagging the unsung hero of cloud management.
It really is. So this company wants to make sure that all its EC2 instances, RDS instances, and Redshift clusters are tagged with specific key value pairs.
Makes sense. Tagging is crucial for organization, cost allocation, and security.
Exactly. But they don't want to do it manually. What's the most efficient way to enforce this consistent tagging?
AWS config rules are the answer here.
Config rules. Tell me more.
Sure, you can set up a config rule that automatically checks if those specific tags are present on all your resources.
Okay.
And if a resource is missing a tag, config will flag it so you can fix it.
So it's like having a tagging robot that patrols your AWS account.
Precisely. Make sure everything is labeled correctly.
I like it. All right, question 570 takes us back to online gaming. This time, we need to design a backend for a multiplayer game that uses UDP communication.
Okay, so real-time gaming, we need low latency.
Extremely low latency.
Yeah.
And the backend has to be deployed in multiple regions to handle players from all over the world.
So global reach and high availability.
Exactly. What's the best approach for a scenario like this?
This calls for a combination of Amazon CloudFront and EC2 instances. So use CloudFront's global network to cache static game assets closer to players. That'll minimize the lag. Then, for each region, deploy EC2 instances to handle the dynamic game logic.
Okay, so CloudFront for the static stuff and EC2 for the dynamic stuff.
Yeah.
Got it. But how do we connect those two?
You configure CloudFront to use an Origin Access Identity, or OAI, and you associate that with your EC2 instances. That way, you restrict access to your Origin servers, but CloudFront can still retrieve the data it needs.
So it's like having a network of gaming servers around the world, with CloudFront acting as a super-fast content delivery system to keep things running smoothly.
Precisely.
All right, question 571 is about disaster recovery for data stored in S3. The company wants to replicate their critical data to another AWS region, just in case.
Always a good idea.
It is. What's the best way to do this?
Okay, the easiest way is to use S3 cross-region replication.
Cross-region replication. Got it. How does that work?
It's a simple feature that automatically copies your data from a source bucket in one region to a destination bucket in another region.
So it's like having a backup copy of your data in a separate location.
Exactly. If one region goes down, your data is still safe and sound in the other region.
Okay, question 572 is about finding the most cost-effective way to store customer statements.
Storage optimization is always a good topic.
It is. So this leasing company needs to keep these monthly statements accessible for 30 days.
Okay.
And then archive them for long-term storage.
So they need a tiered storage solution.
Exactly. What's the best strategy for this?
All right, this is a perfect use case for S3 Glacier storage classes.
Glacier. Okay. Tell me more.
Sure. For those first 30 days, they should store the statements in S3 Glacier Instant Retrieval. That's a low-cost storage option for data that needs to be readily available.
Okay.
Then, after 30 days, they can transition those statements to S3 Glacier Deep Archive. That's the cheapest option for long-term archival.
So it's like having different storage shells for your statements. The recent ones are easy to grab, and the older ones are safely tucked away in a deeper archive.
That's a great way to put it.
Okay, question 573 takes us to a media company that needs a central file system for their video files.
Okay, video files, those are big.
They are. So they're using a bunch of different video conversion tools, and these tools are running on both Windows and Linux EC2 instances.
So a mix of operating systems.
Yeah. What's the best way to provide a shared file system that all these instances can access?
For this, I'd recommend Amazon EFS. That's Elastic File System.
Okay, tell me more about EFS.
It's a fully managed file system that's designed to be scalable and accessible from multiple EC2 instances no matter what operating system they're running.
Oh, that's cool.
Yeah. And the general purpose performance mode is a good fit for this scenario. It offers a good balance of throughput and low latency, which is perfect for those large video files.
So it's like having a giant shared drive in the cloud.
Precisely. All those video editing workstations can work together seamlessly.
All right, we're almost there. Question 574 is about connecting EC2 instances in different VPCs and AWS accounts.
Okay, so we're bridging networks.
We are. They need secure communication,
Mhm.
and they don't want any single points of failure.
Right, so redundancy is key.
And they can't have any bandwidth limitations either. What's the solution here?
Okay, the answer is VPC peering.
VPC peering. Got it.
Mhm.
How does that work?
So you create a VPC peering connection between those two VPCs. It's like building a private tunnel that lets instances in different accounts talk to each other directly.
So it's like connecting two buildings with a secure hallway.
Exactly. Seamless and efficient communication, all within the private network.
Okay, we've reached our final question. Question 575 is about building a scalable notification system.
Let's hear it.
This startup company wants to send alerts to their internal teams when new weather events are recorded in their DynamoDB table.
Okay, so real-time notifications.
But they don't want to bog down their main web application with this task, the one that their customers use.
Right, so they need a separate system for notifications.
Yeah, what's the recommended solution?
This is a great opportunity to use DynamoDB Streams and AWS Lambda. DynamoDB Streams captures real-time data changes in your DynamoDB table. So you configure a Lambda function to process those stream records.
Okay.
And then whenever a new weather event is added to the table, the Lambda function sends out those notifications.
To the internal teams.
Exactly. And it's all serverless, so it's super scalable. You only pay for the compute time that Lambda function actually uses.
So it's like having an automated weather alert system that's always watching your data and sending out notifications without slowing down your main application.
Precisely.
And with that, we've reached the summit. We've tackled all 54 AWS Solutions Architect exam questions, plus a few extra scenarios for good measure.
It's been quite a climb.
It has. Listener, you've gained some incredible insights into a wide range of AWS services. You've learned how to design solutions that are resilient, secure, and cost-effective. You're well on your way to becoming an AWS expert.
Absolutely. And remember, the learning never stops. Keep exploring, experimenting, and building.
Couldn't have said it better myself. And as a final thought, I'd like to leave you with this. If you were to design your own AWS certification exam question, what real-world scenario would you use to test the skills of those aspiring cloud architects? Think about it, share your ideas with the community, and until next time, happy learning.